Okay, so to find a derivative, we can use what our textbook has already derived for us. We just have to plug in 2 over t square root of 3 in for the, actually, I'm going to change this. I'm going to make that square root of 2 because I think there's something we can do to cancel out. But we're plugging this in for x in the derivative formula. But don't forget, every time you take a derivative of inverse trig functions, the biggest thing students forget is the chain rule. You got to multiply by the derivative of this innermost function. So maybe let's do that before we get too caught up with the other stuff. This is 2 over t squared. Sorry about the 2 there. Okay. So that's the same thing as 2t to the negative second. I haven't taken a derivative yet. Just rewrote it. If I do take a derivative, the power rule can help us. The negative 2 comes down and multiplies, and then it gets reduced by 1. So this is the derivative of this. Or in other words, it's negative 4 over t to the third. Okay, so I think that's it. Let's just jump right into the formula. It's the derivative of inverse cosine is negative 1 over the square root of 1 minus the square of your argument. So this is 2 over t squared. That's like our x in the formula. We still need to square it. And then I need to multiply that because of the chain rule by negative 4 over t to the third. Okay, so unlike the other problems for videos I've just made, the book does rewrite this a bit. So let me see what we can do. The negative 1 times negative 4, that one's nice and easy. We can multiply those. And then the denominator, this is t to the third out front. T to the third, I just moved that out front of the square root. And this is 1 minus 4 over t to the fourth, right? Because I use the power rule of I use the rule of exponents, powers on top of powers multiply. So that t squared got squared. So I think what the textbook did for the answer they have, sorry, I thought I knew what the textbook did and I went down the wrong path. So let me show you where we were. So this is 4 over t to the fourth. I don't remember when I cut the video. That was the same spot. So what the textbook, I'm pretty sure, did was they said, hey, this t to the third, we can multiply it inside there and hopefully make something cancel out, okay? So watch what I do here. This is the same thing as t times the square root of t to the fourth, and then times this square root. Okay, because I don't like having variables in denominators if I can avoid it. That helps me make sure I don't have any divide by zero errors. So I thought about how I could rewrite t to the third. T to the third is the same thing as t times t squared, right? And this is t squared. Square root of t to the fourth, the powers on top of power would multiply. 1/2 times 4 would make 2. And the whole reason I put it inside a square root, I didn't just pull that out of left field, is because now that it's a square root, it has the same power as these numbers. So we can multiply that t to the fourth to everything inside that parentheses. Inside that radical. So the t to the fourth multiplied to everything inside. T to the fourth times 1 is t to the fourth. And then t to the fourth times 4 over t to the fourth is just 4. Okay, so I think that's pretty close to how the textbook did it. I have a slightly different variation of the problem, but that's what you want to do to finish out your problem. That's our derivative.